Good day, madam. I am Chimawai. My metric number is 271639. Today, our group is going to present about the application of calculus in architectures. Architectures is the design of buildings and other physical structures with the combination of art and science. The timelines below show us about the historic development of architectures. The Neolithic period is the origin of architectures. During the ancient Egypt period, humans construct houses by using sandbag mud as wood was not widely available. The powerful rulers also construct themselves marble, pyramid, temples, and shrine. When colonies around the world, the buildings shaped into classical architectures. The regular plans of temples show us that builders apply symmetric and proportion theory. Comes to the Byzantium era. Builders construct domes roof with brick instead of stone and the design is in classical form. In the early of medieval period, mostly, the building like church and castle were constructed in the design of thick wall and heavy piles. Continue with the era of Baroque style. The design of church is dramatic, which include irregular shape and extravagant ornamentation. The Rococo style appear in the last phase of Baroque period. There are sweeping curves involved in the building design. Next is Art Nouveau. The building constructed in a schematic shape, arch and Japanese decoration. The timeline is followed by Baroque art. With this design, buildings have some characteristics can be highlighted, which is order, symmetry, and the design is formal. In the early of 20th century, the buildings have strong vertical line and great height. This design called Neo-Gothic architectures. And the development is continued with the Art Deco, and this design is inspired by the architectures of ancient Egypt. Today, the building around us is in modernist style, and it includes postmodern architectures that combine new ideas and traditional form. In the field of architectures, there are some influential architectures. First and foremost, Louis Sullivan. He has been called as father of skyscraper and fathers of modernism. Second is Ludwig Mies van der Rohe. The new National Gallery in Berlin was his final project, and this building certified his modernist aesthetics. Last is Alvar Aalto. His buildings embodies a unique functionist, expansionist, and human style. Now I would like to discuss about the application of calculus in architectures. Calculus is widely used in calculating the building's area and methods of difficult geometric form structures. Buildings that involve design with non-uniform shape, like curve, integral calculus will be used to calculate the area under the curve or the area of two intersecting curves. Integral calculation also used to calculate the materials used for the construction, as it is useful in minimizing the amount of materials needed as well as the cost of the projects. Next is importance of architectures toward the understanding of our world. The importance of architectures involved as a protection from environment, as buildings provide shade and keep warm from rain and wind. Architectures with infinite changeable area allow humans to carry out various activities to improve their human life. The importance of architectures also involve ability to tell tales. By visiting iconic buildings around the world, humans can gain knowledge and architecture's experience. Next is benefit of architectures toward the understanding of our world. The benefit of architectures involve earth-friendly environment. This can be achieved by recycling and maximizing energy, like not beginning to waste the materials. Second is solve the problems of housing demand. Modern architectures allow humans to construct with higher buildings like condominium to overcome the problems.
Hi madam, I'm Ong Jia Yi with matrix number 269674. I'm here to present the key concept of our group assignment. Integration is widely used in architecture. It can be categorized into two groups, which is definite integral and indefinite integral. Indefinite integral will branch into proper integral and improper integral. Proper integral is usually used when designing a product and identifying the volume of material used. Trigonometry is a branch of mathematics that mainly studies triangles and investigates the relationship between the size and angles of the triangles. Hence, trigonometry can say that it helps in finding length, height, and angles of different triangles and used a lot in real-life applications. Trigonometry substitution can be said that it falls heavily in architecture, especially when developing infrastructure with fulfill customers' needs and calculating the amount of certain material is needed. The accuracy of calculation through trigonometric substitution will show the architecture in determining the sizes and proportions, and the most efficient way can use for the. In calculus, trigonometric substitution is a technique for evaluating integrals. Besides, trigonometric substitution also used to simplify integrals containing radical expressions in the integrand. In some occasions, sometimes we need to choose a step by using Pythagorean identities or power-reducing identities before obtaining the final answer. There are three cases involved in trigonometric substitutions. Case 1. Radical expressions in integral containing x squared minus x squared. Case 2. Radical expression in integral containing x squared plus x squared. Case 3. Radical expressions in integrals containing x squared minus a squared. Thank you.
Good afternoon, madam. My name is Chua Chen Yong and my matrix number is 271130. So I'm going to present the method that we use in this assignment. Related to the application of integration in architecture, a proper integral is important to design products and identify the volume of material used. A proper integral has neither limit infinite and from which the integrand does not approach infinity at any point in the range of integration. There are two substitutions called integration by substitution, U substitution, and trigonometric substitution. After applying trigonometric substitution, trigonometric identity is needed to convert the trigonometric function. In this assignment, we are using case 1 integrands containing a square minus x square for both examples. So under the help of substitution and trigonometric identity in integration, application of integration in architecture such as the design of structure by fulfilling customer needs and the amount of material used required to construct a structure can be determined. Besides that, integration is needed to identify the volume of a solid of revolution. For a definite integral, the bounds change once the substitution is performed and are determined. Since we transform into another new equation, the upper and lower bounds must be changed also. Integration by substitution, also known as U substitution, is a method of evaluating integrals. This method is used to transform one integral into another integral that is easier to compute. Thank you.
Hi, madam. Now, my turn again to give some explanation on example and analysis. The first example is, a customer requests to have an underground fish pond. The customer wants the fish pond's water surface has a semi-oval shape. Given that the customer wants the pond have water volume of 1000 liters, we are requested to find the value h, the depth of the pond. First, we know that the water volume is equal to the volume of the pond, which also equal to the surface area of semi-oval multiplied with the height. 1000 liters is converted to 1 meter cube. To get the surface area of semi-oval, we must identify the surface area under the curve. So we get this. In the surface area of semi-oval, we can notice that this function is similar to this form. Then trigonometric substitution method is used. We differentiate both sides and get this. When we transform the integral by substitutions, the upper bound and lower bound also will be changed. New upper bound and new lower bound have to be identified, and then we get this. And this part, we notice that can be changed to cos delta by using the trigonometric identity. At this part, we also notice that can be changed to this by using trigonometric identity. At last, we found that the surface area of semi-oval equal to pi. So, using pi multiplied height is equal to 1 meter cube. Thus, we get 1 over pi, which is the depth of the pond. Thank you.
Good morning, madam. I'm Li Ting, matrix number 271141. Today, I'm going to discuss the examples and analysis of example 2. So for this example, there is a customer want to have a metal table. In this figure, x show the length of the tabletop and y is the height of the tabletop in cm. So find the volume of the metal necessary to be used to create metal tabletop given that the thickness of the tabletop is set at 3 cm. Okay, first we have to find the surface area of the tabletop and then we can determine the volume. To find the surface area, we need to identify the area under the curve by integrating. Now, the function beside cannot be integrated directly because x and y is mixed together. So we need to find y. Now we have positive and negative of y. So we have this, and by looking at this point, we notice that this have a form of this. So we use U substitution. Trigonometric substitution cannot be used directly because there is expression 2. After we let U equal to 2s and we differentiate both sides. We substitute again and we get this expression. So at here we can use trigonometric substitution. We let U equal to 50 sine delta and we differentiate both sides and get this. Then new upper bound and lower bound for the delta must be found. Now we are going to find the surface area of tabletop. We substitute and rearrange and become like this. So from this expression, this is equal to cos square delta by using trigonometric identity from here. After that, we use trigonometric again and become this. Then we calculate and substitute upper bound and lower bound and we get 1250 by cm squared. Then we take the value just now we found and multiply by 3, which is the thickness. Then we found the volume of metal necessary to be used equal to 3750 by cm cube.
Good morning, madam. My name is Henke Eng and number metric is 269659. Today, I would like to conclude our group project. Application of calculus concept is important to the area of architecture and other area. Application of technique of integration into the area of architecture. In this project, application of calculus in architecture able us to figure out the design of a structure by fulfill customer needs and identify the amount of a material that necessary to construct a structure. So in this project, we use the integration of trigonometric substitution when the form are square root of a square plus s square, square root s square minus s square, or square root s square minus a square. From the example 1, the form of the function is square root s square minus s square. So we apply s equal to a sine delta to find the depth of the pond. From the example 2, also in the form of square root s square minus s square. So we also use U equal to a sine delta to find the volume of metal necessary to be used to create the metal tabletop. So this is the example and solution of our group project. Thank you.